Okay, so 4.5, solving rational equations. All right, so what we're gonna do, let's just do really some examples. I think is the best way. That's what most of the things I find in this one is just best to just get doing examples. So it says salt water is flowing into a large tank that contains pure water. The concentration of salt in the tank, C, in grams per liter, so grams per liter, at time t in minutes is given by the formula. So that was all really confusing, but really you've got concentration and then you've got T stands for time. And then they say determine the time, so T, when the salt concentration in the tank reaches that, right? So that's what our C would be. So really we just get to take that number, just throw it right in for C, right? So let's just do that first. So we're going to say when 3.75 is the concentration, then our formula would be 10T over 25 plus T. And it wants us to, that was a weird T, it wants us to solve for T, right? And that's the idea here for this lesson. Just a little bit, just so we don't get them confused, I want you guys to notice in this case, right? Actually, in all of these, what the difference between this lesson and the other lessons has been. It's this equal sign, right? Because we have this equal sign, that makes this an equation. So we're actually going to end up with a solution. We're going to end up with like, x is equal to 3 or x is equal to 4 or something like that, right? When you guys were dealing with expressions, so maybe like you had x over x minus 4 or whatever, right? That was an expression because there was no equal sign. It was just this one term. So all we could do before was just simplify that or add it or multiply or whatever we were doing, right? But in this case now, we're actually going to come out with one number, and that's because of the equal sign there, right? That's what it means to solve something. Okay, so we're going to handle that a little bit different, a bit more algebra. Okay. So back to our question here. So now we've got two t's to solve for here, right? And really my issue, what I'm going to do here to begin with, is I don't like this part being down in the denominator. So it's kind of a bit of a rule of thumb. Usually what we want to do is get that out of the denominator. And the way we're going to get out of there, right, is that right now I'm dividing by that. So I'm going to multiply both sides by 25 plus t. Okay, so they'd cancel on that side. And then on this side, you'd have 25 plus t, still in brackets, right? And now at this point, I know it's annoying because you've got a decimal there, but we would distribute, right? We'd get rid of those. We get rid of those brackets. So you'd go 3.75 times 25. So 3.75 times 25. So we'd get 93.75. And then plus, and then it's going to be 3.75 times t, which is just 3.75 t. That's all you can do. And then is equal to, and then all that's left over here is just 10t. All right, now I've got multiple terms with t in them. So generally the way that we do this is we want to get all the t's on one side and all just the constant numbers on the other. So that's what we'll do. We'll subtract 3.75t from both sides. So minus 3.75t. So we're going to have, so left over here, just 93.75 is equal to 6.25 t. And then very last step, we just need t on its own. So we're going to divide both sides by 6.25. 6.25. And that all comes out to 15. So t was equal to 15 there. So that would be the time taken in minutes, right? So that would be minutes there. All right. So that's about it for the word problems that we're going to do. Well, so far anyway. All right, now, just like I said, lots of examples here. So let's keep going with this one. So this one says solve x on each question here. So here's our question. Now, what we want to do Well, you could handle these a few ways, right? Like I've got 4 plus 3 over 2. If I really wanted to, right? I could actually just get a common denominator, right? I could call that, 8 over 2 and then add those across. That would make things a little easier. But that's one way to do it. But the other way I'm going to show you guys here is that we can actually just get rid of the stuff in the denominator, right? That's going to make my life a lot easier if I was just dealing with everything up in the top. So what we do on these ones is we try to just cancel everything in the bottom. So if I wanted to cancel, the 2 in the bottom here, well, what I would have to do is I'd have to multiply by 2. And if I wanted to cancel the x, I'd also have to multiply by x, right? Because those would cancel with each other. But here's the idea is that whatever I do to one term, whatever I do to like this term over here, you actually have to do to every term, because then I'm like multiplying everything by the same number. It doesn't actually change any part of the equation. So I can get away with multiplying by 2x as long as I multiply the tops of all of them by 2x. And then this part's actually kind of weirdly satisfying, is that you can just go to town crossing things off now. I've got 2x in the top here, cancels with 2x on the bottom, right? So that's gone. And then 2 and 2 gone, right? And then you just get to have like, what's left on the top here. So you've got 2 times 4. So that's going to be 8, and there's still an x there. And then plus, so there's still a 3, and that I didn't cancel that x, right? I just canceled the 2 in that case, that 2 and that 2. So I've still got 3x, and then is equal to, and then the only thing on this side is 9. So I know that looked a little confusing, but just with practice, I think you guys will get more used to it here. So this is going to be nice now, though, because now I'm just left with 8x and 3x. Okay, well, those are like terms. I can just collect those like terms. 8x plus 3x is 11x. So 11x is equal to 9. So then very last thing, I'm going to get rid of that 11 that I'm multiplying right now by dividing both sides by 11. So x is equal to 9 over 11. Okay, now that I have this answer, I better warn you that sometimes our answers won't be answers. And the reason for that, well, let's go back up here before I did all this stuff, right? We had our non-permissible values, right? We had our restrictions. That is what I was calling them before. They go by a lot of names. But I'm not allowed to divide by 0, right? So right off the bat, I could have said x is not allowed to equal 0. So if I would have done all my algebra and found 0 as an answer, then that wouldn't be an answer. It's called an extraneous solution. So it's like an answer that's not an answer. Okay? All right, so let's move on to another one. This really is the idea, though. Like if you guys got this, if that made sense to you, then the rest of it's the same stuff. It's just maybe with some more factoring and that kind of stuff. So let's carry on. Let's do this one. All right. So again, I want to get rid of the stuff in the bottoms of these equations, right? I want to get rid of all that stuff. Okay, well, the way I can get rid of that x plus 4 is by multiplying by x plus 4, right? That would do it. I get rid of that. But I also want to get rid of this x minus 7, right? So really the idea here is if it shows up at all, you're going to multiply both sides by that, right? So it's going to be x minus 7. So I need to multiply the right side of this guy by x plus 4, x minus 7. And I also have to multiply the left side of it by the same thing, x plus 4, x minus 7. Okay, now it looks like I've done a bunch of stuff, right? But I've done it to both sides of the equation, so I can get away with it. I didn't really do anything. Now, what's going to happen is that I've got x plus 4, x minus 7 on the right here. This x plus 4 cancels with this x plus 4. Okay? And this x minus 7 cancels with this x minus 7. And now everything's out of the denominator. So now I'm pretty good to go. So let's clean the top up here. So now on the left side here, what we have left is I still have that 6, right? I didn't touch that. So I've got 6. And then now I've still got an x plus 4. And on the right side of the equation, I've got 3, and then I've still got an x minus 7. And now I got to get rid of the brackets, right? So I'm going to distribute into both of them. So 6 times x is 6x. 6 times 4 is 24. 3 times x is 3x. And then 3 times negative 7 is negative 21. All right. Now, same thing. I'm going to get my x's on the same side. So I'm going to subtract 3x from both sides. So minus 3x and minus 3x. So I'll do this in 2 steps here. So we've got 6x minus 3x is going to be just 3x. Plus 24 is equal to negative 21. And then I'll subtract 24 from both sides. So minus 24. So I've got 3x is equal to, and then negative 45. Okay. And then very last thing, we're just going to divide both sides by 3. So x is equal to negative 15. And again, once you get that answer, you got to check that with your restrictions, because I could have gone back up here before we canceled those things, right, in the denominator there. X was not allowed to equal, well, 7 in that case, right, because that'd be 7 minus 7 would make that 0. So it can't be 7, and it can't be negative 4. So if I would have got an answer of either one of those two, then it would have been an extraneous solution. It wouldn't have been an answer. Okay. Next one. You know what? That one's a lot like the last, so I'm going to skip that one for the sake of time here. Let's get into the little bit tougher ones maybe. Okay. So yeah, we got this mess going on, right? I've actually got 3 terms. Like they get a little bit tougher now, right? When I've got 1, 2, 3 terms, because whatever I do for one, I have to do for all of them, right? So I got to figure out what to multiply the tops by all of them by. Now, this is going to get extremely messy if I say, okay, well, there's an x minus 3, and there's an x squared minus 3x. Don't write this down yet. I can multiply everything by this. That'll actually work, but it's going to get really complicated really quick. What I want to do instead is see if there's anything common, let's say to like this one and these two. And I can't really see it yet, but what if I factor it? Let's actually write this whole thing again, but I'm going to factor what I can. So I'm going to write this as 18 over. And then looking at this one, they both have an x. So I can factor an x out of that. So I'm going to factor out x, and then I'd be left with x minus 3. Okay? And that's equal to, and then I can't really do anything with the rest of it. So 6 over x minus 3 minus 5 over x. All right, now this is going to be a lot nicer because I can see that I've already got an x, and like that's these ones, right? Like an x and an x, a 3, or an x minus 3 and an x minus 3. So that's going to allow me to multiply by less stuff, right? Because I'm going to be able to cancel everything in all those terms as long as I multiply it by x. Here, I'm going to make that different color maybe. As long as I multiply it by an x and an x minus 3. Right? And I have to multiply every top by the same thing. So it'd be an x times x minus 3. This term as well would be x times x minus 3. And then this one too, x times x minus 3. And then this is where, like I said, I weirdly enjoy this, where it's almost like, I was telling the kids, it's almost like the same sort of like itch where like popping a pimple. Like it just feels like you're like getting rid of it. It's good. Kids always think I'm weird that way, but other kids have said the same thing. They're like, they actually enjoy this part, but you can just go to town crossing things off now, right? So you've got x times x minus 3 on the left there. All of that cancels with all of that. Okay. And then on this one, you've got the x minus 3 and the x minus 3. They all cancel. And then on the other one here, you've got just the x and the x cancel. So I get to get rid of all of that. And notice there's nothing left in the denominator in any of it, right? So as soon as I've done that properly, then I've just got straight algebra like we've been doing. So let's clean it up now with what we have left here. So we've still got 18 is equal to, and then I've got 6, and I never did cancel that x, so it's still 6x. And then minus 5, and then I've still got that x minus 3. So and it's going to be x minus 3. And don't forget to put it in brackets because I'm going to have to expand that out. Okay, so that's exactly what I'm going to do next step here. I got to get rid of these brackets, so I'm going to expand that 5 into both of those, like negative 5. So we'll have 18 is equal to 6x, and then negative 5 times x is just negative 5x. Negative 5 times negative 3 is positive 15. And then, yeah, we're pretty good to go here. This one's set up nice already. Let's actually just collect those like terms. Let's go 6x minus 5x. That's just going to be x, so that'll be nice. So we've got 18 is equal to x plus 15. And then I just need to get rid of the 15. So that's going to be minus 15 minus 15. So x is equal to 3. All right, so you'll say, yay, we got 3. There we go. That's the answer, right? Wrong. That's not the answer. That's not the answer because, right? If I go back to the beginning when I was setting my restrictions, right there, right? Because of that spot, if I put a 3 into that, right? If I tried to put the 3 back into this equation, that's going to be 3 minus 3. That's going to have me dividing by 0. X is not allowed to equal 3. So you know, I should have had that at the beginning. You'd say x was not allowed to equal 3 or 0 either, right? Because of that one, can't be equal to 0. So if I get either of those answers, it's not right. And I did get that answer. I got 3 for an answer. So you'd say no solution. And that could be the case when you guys are doing questions in the homework too, right? That you get, like, you can either put the numbers in or some of them might have no solution. So just check on those ones, right? Okay, so that's the idea. I'm just going to give you guys a few more actually that are on the assessment there too. I'm even going to just use the same ones, but the numbers change, so they'll be slightly different for you, right? But so here, let's go. Let's do. What was it? Sorry, I had a good one lined up, but I lost it. Okay, there we go. All right, so we've got, this is about as tough as it gets. So we're going to have x plus 21 over x plus 6. And that's equal to negative 4x over x plus 6. Well, I guess it's not that bad because we don't have to really factor anything. But okay, so we've got the same type of thing going on, right? Where I need to get rid of this denominator, right? So that's my issue right now. And yeah, so what we can do, like, I know that I need to multiply everything by, well, x plus 6. Right, x plus 6 will do it, because if I multiply this by x plus 6, that'll cancel the denominator. But I have to do it to every term. So that's going to be x plus 6. And then this one will also be x plus 6. Okay, so then we get to go to town canceling. So I can't really do anything on the first one, but on the second one, to cancel that one and that one. And on the last one, same thing. That one and that one. So they all cancel. And then we can just clean it up. So here, I'll write it out once without expanding. So you'd have x times x plus 6, and then plus, and then everything canceled there. So I've just got 21, and then is equal to negative 4x, and that's it. Okay, so like before, if we have brackets, I want to get rid of those brackets, so I'm going to expand into that one. So x times x is x squared. X times 6 is 6x plus 21. is equal to negative 4x. And then, okay, it's finally apparent here that I've got an issue. What we've been doing so far is I've been getting my x's on one side of the equation and my number and my just constants or just my numbers on the other, right? But here's my issue is like, now I've got an x squared and an x. Which one do I get on their own, right? Like I can't really combine those because those aren't like terms anymore. So if you remember, we have a different way of doing these. These ones, if I've got an x squared and an x in it, the way I do this is I get everything over to one side of the equation. And we're going to be doing this a lot more in the next unit as well. But we're going to get everything over to one side of the equation and 0 on the other side. So we're almost there. I'm just going to move this guy over here, right? So I'm going to bring 4x. I'm going to add 4x to both sides. So those cancel. So plus 4x. And if I write that all out again, we've got x squared plus 10x plus 21 is equal to 0. All right. Now, what we can do with this is we can factor it now. We can figure out what x is, and I'll give you a hint here. There's actually going to be 2 different x's. There's going to be 2 different values that are going to work here. So I'm going to factor this and see what would make it equal to 0. It'll make a bit more sense here in a second, I think. So let's just factor this first. So we've got our brackets. They both get an x. And I'm looking for numbers that multiply to 21 and add to 10. Okay, well, 7 and 3, right? That would do it. And both positive. All right, so now all I've done is I've rewritten this thing just in factored form. But now the idea here is that I can look at each of these things individually, and I can say, okay, well, if this one, right? If I put a negative 3 in for x here, if I put a negative 3, then that would be negative 3 plus 3. That would make that 0. And then if this was 0, the whole thing would be 0, right? Because anything times 0 is 0. So what it's going to be here then is I can see right from here that x is going to be equal to negative 3. And I can see from this one that if I put a negative 7 in for x, then that would make that 0, which would make the whole thing 0, which would make this true. Right? So from here, I can see that x would have to be equal to negative 7. And there you go. Those are my 2 answers. So then again, just quickly, what we do is look back up to the beginning and you'd say, okay, is my restrictions on that one, right, would have been x is not allowed to equal negative 6. So we got lucky. If negative 6 would have been one of my answers, then it wouldn't have been an answer. Like let's say if this was negative 6, I'd cross that out and say that's not an answer. And you only would have had one answer instead. Okay, but we're good. We didn't run into that restriction, so we're okay.